Greetings, welcome to my series of Paradox Debunked presentations, PDP, where I offer my take on how to refute certain paradoxes we encounter in our academic culture. In today's presentation, we are gonna be dealing with the infinite hotel paradox created by Mathematician, and yes, my title says just that, a big mathematical blunder this paradox is. Now, before analyzing this paradox, let us just look at a popular clip that explains what this paradox is all about.
In the 1920s, the German mathematician David Hilbert devised a famous thought experiment to show us just how hard it is to wrap our minds around the concept of infinity. Imagine a hotel with an infinite number of rooms and a very hard-working night manager. One night, the infinite hotel is completely full, totally booked up with an infinite number of guests. A man walks into the hotel and asks for a room. Rather than turn him down, the night manager decides to make room for him. How? Easy. He asks the guest in room number 1 to move to room 2, the guest in room 2 to move to room 3, and so on. Every guest moves from room number n to room number n plus 1. Since there are an infinite number of rooms, there is a new room for each existing guest. This leaves room 1 open for the new customer. The process can be repeated for any finite number of new guests. If, say, a tour bus unloads 40 new people looking for rooms, then every existing guest just moves from room number n to room number n plus 40, thus opening up the first 40 rooms.
Okay, so the bar has been set, and now I have to show how it is not possible to fill a fully booked infinite hotel with even more people, as the paradox suggests. To do this, we're gonna engage in some minor statistical work and some logic, and to begin with, we will first establish what the statistical implication of the term fully booked is before moving on. So if we have a number of hotel rooms denoted by R, a number of hotel guests denoted by G, and a declaration that the hotel is fully booked, then provided it's only one person per room, the value of R and the value of G must be equal. This can be justified by the fact that provided the hotel requires one person per room, a 10-roomed hotel is only fully booked if it contains 10 hotel guests. More than 10 guests will be overbooking, less than 10 guests will be underbooking. Now, the number of hotel rooms in our paradox is infinite, and therefore we will set R as equal to infinite H. As for the number of people, since it has been established that a hotel statistically needs an equal number of rooms and occupants in order to be declared fully booked, it then follows that the number of hotel guests G must be equally as infinite as the number of hotel rooms R. And because G must be equal to R, G must also be equal to infinite H. Thus the equation G is equal to R is equals to infinite H. So I hope we can all agree. A fully booked infinite hotel must have a number of hotel rooms that is equally as infinite as the number of hotel guests in order to be considered fully booked. Now, moving on, it is alleged in the paradox that in order to create space for any finite number of additional guests, we just need to relocate people in the hotel and create vacancies, even though this infinite hotel has just been declared fully booked. And an example was also given where if you were adding, say, 5 additional guests, you just have to move every occupant from room number n to room number n plus 5. In my opinion, this is a very big blunder that arises from not being rigorous enough to define the mathematical implications of the phrase fully booked. So here is how to prove this paradox wrong. Before talking about the additional guests, we already saw how the term fully booked led us to the conclusion that the number of hotel rooms R is equally as infinite as the number of hotel guests G. So if we were to add 5 more guests to this hotel, this is what it should look like statistically. With the number of hotel guests G originally being infinite H, then after the additional guests arrive, G will now be infinite H plus 5. And with this new information, I will shortly demonstrate the big problem that arises from trying to create space by relocating people in such a hotel with such statistics. But before I do, let me give some references that we are gonna have to work with. 1. For a 10-roomed hotel with 5 guests, the n+5 method works. Because if the guests are initially in room numbers 1 to 5, the last guest in room number 5 can be moved to room number n+5, which equals 10. And there is no problem because room number 10 already exists in this hotel. 2. If the same 10-roomed hotel had 8 guests, however, the n+5 method doesn't work. Because with the guests in room numbers 1 to 8, the last guest in room number 8 has to now move to room number 13. But this hotel only has room numbers 1 to 10. So moving hotel guests in such a situation is wrong, because we have to build more rooms in order to create the space needed. Now that we have made these references, let's dive back into the infinite hotel situation and demonstrate the big problem. So we already set the number of rooms in this hotel as infinite h, which translates to the numbering room number 1 up to room number infinite h. And as for the hotel guests, there were initially infinite h guests, but now there are infinite h plus 5 guests, which can be translated to guest number 1 up to guest number infinite h plus 5. And to create space, as the paradox alleges, we have to move all prior guests from room number n to room number n plus 5, meaning in this infinite hotel, guest number 1 has to move to room number 1 plus 5, guest number 50 moves to room number 50 plus 5, guest number 2000 moves to 2000, guest number 2000 moves to room number 2000 plus 5. And lastly, guest number infinite h moves to room number infinite h plus 5. But wait. Didn't we just assert that there are only infinite h rooms in this hotel? That is what I remember. You see, just like in reference 2 where guest number 8 had to move to room number 13 which didn't exist, we now have a similar situation where guest number infinite h has to move to room number infinite h plus 5 in a hotel that only contains infinite h rooms. Room number infinite h plus 5 doesn't exist in this infinite hotel, which makes moving people around the wrong option that has long been accepted as the correct way of creating space in this infinite hotel. To really create space in this hotel, we would have to build new rooms to create room number infinite h plus 1 to room number infinite h plus 5, which will then be given to the 5 additional guests that arrive. And so this is the problem that arises from not being rigorous enough to define implications of just one concept in mathematics. Let me be clear. As long as this alleged paradox is about a hotel that starts off as fully booked, then the concept fully booked must imply a mathematical consequence that the number of infinite hotel rooms is equal to the number of infinite hotel guests. And so every additional guest that is added to this hotel will make the number of hotel guests more than the number of hotel rooms. Thus, I find it very illogical to even allege the creation of vacancies in such a hotel just by moving people around. You will have to build new rooms. Just a side note, if the infinities in the paradox were anything but equal, but more clearly, if there was an infinite hotel not fully booked but filled with an infinite amount of people, then all the reasoning presented in the alleged paradox becomes plausible, provided the infinite number of hotel rooms is vastly bigger than the infinite number of people. This is because, as Neil Tyson put it when he blew my mind, some infinities are bigger than others. If there is a reason that more on this topic has to be presented, I may make a follow-up video on why I added this side note. However, unless there is someone who can demonstrate the mathemagic that will prove me wrong, I will have to declare the infinite hotel paradox